Hi guys, welcome to our channel Let's Decode. In this video we will know how to generate basic signals like step, impulse, ramp, and exponential signals with and without built-in functions. Before starting this video, if you still didn't see our previous video, do watch it. Okay, let's get started. First start with unit step signal. A unit step signal UN is 1 when n greater than or equal to 0 and 0 when n less than 0. Range of n is from negative to positive large number. Let's fix the range from -5 to 5 only for better understanding. So the respective UN values are like this. Let's make this in MATLAB. Plot them using stem function. Run the script. Yup, we got the signal. To understand it better, change the limits of x and y axis using xlim and ylim function. Set the x limits from -6 to 6 and y limits from -0.1 to 1.1. Run the script. Okay, now we can see it clearly. Now change the color. To know how to give color and marker type, do watch our previous video. Yup, we got it. Now label the x and y axis. Set the title to the plot. Now run the script. Yup, we got it. Increase the range of n to 6. So add 1 to UN. You can see that we got the value at 6th position also. But if we want to change the range, we have to add 1s or 0s every time. Instead, we can try this way. Give the range by indexing method from -5 to 5. I hope we can write the condition for UN like this. Using logical relation, if n is greater than or equal to 0, then UN is 1, otherwise it is 0. Now run the script. Yup, we got it. Now increase the range. Oops. Where are the remaining points? As we fix the axis from -6 to 6, we cannot observe the remaining points. Now increase it to 10. Okay, we got it. Instead of changing it every time, we set the limits from 1 point behind the initial point and 1 point beyond the final point. Now change the range again. Yup, it's working fine. Unit impulse signal looks like this. When n equal to 0, del n is 1, otherwise it is 0. Fixing the range from -5 to 5, n vector looks like this, and del n looks like this. Now generate this in MATLAB using logical relation. Create n vector from -5 to 5. Whenever n is equal to 0, x is 1, otherwise x is 0. Now plot it using stem function. Run the script. Yup, we got it. X is 1 at 0 and 0 at remaining positions. Change the color and marker size as we did for unit step signal. Okay, we got the X mark with red color. Now add the limits and labels for the plot. Yup, we got it. Let's see how to generate ramp signal. Unit ramp signals looks like this. Rn follows n when n greater than or equal to 0. Or it can be represented by n multiplied by UN. So the sequence looks like this. Coming to MATLAB, we will use unit step sequence multiplied with n as given here. Then plot the sequence using stem function. Yup, we got it. Now change the color and marker size of the plot. Also give the labels and limits to the plot. Now run the script. Oops. Remove this and run it again. It's working, but we can't see the total sequence completely. This is because of the y-axis limits. Now change them like this. Hope you understand why we are giving this. If not, ask us in the comments section. Run the script. Yup, we got it. At 5 the value is 5, at 4 the value is 4, similarly for the other points also. To understand it at first glance we use grid option. Grid command draws the lines of the points so we can track the values accurately. Okay, let's move forward. A real exponential sequence looks like this, with the equation e power n, where n is the range and a is the scaling coefficient. Now make this in MATLAB. Create the n vector and assign a value as 1. Now make x as the exponential of a and n. Plot the sequence using stem function. Okay, we got the sequence with value at 0 as 1 and increasing exponentially later. If we change the sign of a, then we get the inverse sequence where the values decay exponentially. If the coefficient is increased furthermore, then the sequence decays more rapidly. Similarly grows for the opposite sign. Now change the color, size and limits of the plot. And label the axes and the plot. Now run the script. Yup, we got it. But there is no significant change in the limits as the values is very large. This is the simple real-valued exponential sequence. Now for the case of complex exponential sequence, we just make small changes to it. So, copy the previous code and paste it here. Here instead of a, we give 1 plus 1j. Now run the script. As the sequence is imaginary, we got the error. Let's remove these axis limits and run the script. Let's clearly draw this sequence again using plot function on the same axis. Okay, this goes like this. Let's decrease the step size to get smooth curve. So, the sequence goes like this. Even for large range also, we get the approximate sequence. Change the coefficients. Okay, now let's encounter these warnings. Here it's saying that the imaginary part of the x or y are ignored and only real component is used to plot. Now remove the first arguments of the stem and plot function, which means that we are plotting the imaginary axis versus real axis. Now run the script. This is how an imaginary exponential sequence looks like when we plot an imaginary axis. Stem won't take the two arguments, so mention them separately. Yup, we got it. If we want to shift the signals, how can we do that? Before that, let's see how do we represent that. We represent the shift by n0, and the conditions also change like this. Now create a function step signal to generate the step sequence for given arguments of starting step, starting of the sequence and end of the sequence. Create vector n from start sequence to end sequence. If n minus start step is greater than or equal to 0, then it is 1, otherwise it will be 0. We can call the function like this. Create a sequence from -5 to 5 with the step at 0. Yup, it looks fine, but the x-axis is different. So, now create the unit step sequence and store them in x and n. Then plot them using stem function. Yup, we got it. Now change the starting step point. We can observe the change of step here. Check for another value also. In the similar fashion we write for the impulse sequence like this. When n minus n0 is 0, the sequence is 1, otherwise it is 0. Now create the function in MATLAB as we did before. Check for different ranges and different step points. Sorry, it's n here, not x. It's working fine, let's move forward. Here we generated 4 signals. If we want to plot them in the same window, we make use of the subplot function like this. As we have 4 plots, we divide them into 2 by 2 tiles and put the unit step sequence at first tile. Then we put the impulse sequence at the second tile, followed by ramp and exponential sequences at third and fourth tiles respectively. Now run the script. Yup, we got it. To avoid this manual creation of basic sequences, MATLAB provide us some built-in functions to generate step and impulse sequences. First, we will generate the step signal. Create the t vector ranging from -5 to 5 with steps of 1. Then we generate the sequence using Heaviside function and store it in xt. Now plot them using stem function. The only difference are previous step signals and this signal is the value at 0. In this case the value is 0.5 at 0, whereas in previous case it was 1. Use plot instead of stem. This slant is due to the steps of time. Change the axis limits to see it clearly. Now decrease the step size to 0.01. Now we get the exact signal. Here the step is at 0. If we want to change it, we can directly mention it here itself like this. We can observe the change of step from 0 to 2. Check for some other values. Now generate the ramp signal using this Heaviside function. Yup, we got it. Shift the step to other value. Oops, while changing the start we get different plot because the value at 0 is 0.5, but not 1. Now generate the impulse sequence using dECodE function. Oh, we got a discontinuity at 0. Change the step size to know what's the problem. Oops, even if we change the step also, the plot is same. Let's see what is going on. If we see the elements in xt, we have infinite value at 0. As the value at 0 is infinity. MATLAB cannot point the infinity, so we get the discontinuity at 0. Hope you understand it. If you still have any doubts regarding this, please try to comment. We will meet in our next video. Thank you and sayonara.